Good afternoon, everyone. My name is Venkatesh. I welcome everyone here on behalf of Skilling. I'll be hosting the session today. For those of you engaging with Skilling for the first time, we are an engineering upskilling platform focused on advanced technologies across domains like mechanical, electrical, electronics, computer science, etc. This webinar is brought to you by Skilling's B2B division, which focuses on employee training, upskilling across industries, including automotive, consumer electronics, ITES firms across various verticals. Today's webinar is on rethinking automotive software and SDV architecture. Today's webinar will be taken by Mr. Pratap. He's the practice head for software-defined vehicles and director of enterprise solutions and delivery at Skilling. He has over 13 years of experience in automotive projects across continental Europe, Marelli. He has a strong background in automotive product delivery, industry automation, and business strategy. Before we start the program, please post any questions you have on the chat window. Mr. Pratap will take it up during regular intervals of the sessions. We'll also share a feedback form in the chat window. Kindly take a couple of minutes to fill it up. We'll share the recording of the session to those who wish to require it. Over to you, Mr. Pratap. We are excited to hear from you.
Yeah, hi. Thank you, Venkat. So, hi team. Welcome to the session. So today I'll be taking into a very superficial level in understanding what is software-defined vehicles, and we would be also seeing what is software-defined vehicle, what are the definitions given by uh, different parties, like for example, what kind of definitions they have given for software-defined vehicle from the OEM to Tier 1 to the GCC, etc. Right? So these are the things which we will be looking into, along with what kind of layered architecture are we looking at. Okay, so I'll be taking into that session right now. So let us see the introduction to SDV and its applications right now. So what is a software defined vehicle? So the definition is very straightforward. So any functions that are enabled by software, right, that can be enabled or disabled by software, then we are calling it as a software defined vehicle, right? Any functions in the vehicle, if they are enabled or disabled, then this can be called as a software defined vehicle. And the how the technical implementation is being taken apart here is by decoupling the software from hardware. So previously, all the hardware and software are tightly coupled, but right now we are looking at the decoupling of software and hardware. I'll explain you what is meant by coupling and decoupling in the next slide. So it actually enables your swift and continuous development, and you can actually implement your new functions and software updates. So the benefit for the end user is mostly on software updates that can be updated throughout the vehicle lifetime. So just give me 1 second. Sorry, I just give me 1 second. Sorry for this. I had something. Okay. Yeah. So I'm at this thing, right? We are looking at the implementation of new functions, and that can be happened via vehicle. I mean, throughout the vehicle lifetime, and it actually enables the vehicle to even improve even after leaving the factory. So this is the definition of a software-defined vehicle in an overall perspective. And as I said, there is a difference between hardware coupling, both hard couple and also decoupling of both software and hardware. So what do you mean by coupling? What is meant by tight coupling? So tight coupling is nothing but for example, if you're looking into the project management of any automotive project, right? So you need to wait your hardware prototype to be available to make sure you match it with your software releases, right? Just like whatever you are looking at here, both are tightly coupled, and even the software and hardware timelines have to be matched So if you are in any of the automotive projects, right, I think you might be looking at from your project managers or someone who might be saying that, okay, we need to have the software release that needs to happen before this particular hardware prototype getting released, right? So this is exactly how it used to be till today. But from tomorrow, I mean, even today as well, there's a lot of decoupling that has happened. So whenever I say decoupling is nothing but your both hardware and software are completely not tied together. That means I will not be caring anything about the hardware timeline, but my software timeline has to be I mean, the software timeline has can be adaptable, and even without having a without having a hardware prototype, I can release my software functionalities using CI/CD, the continuous deployment and continuous development and deployment. And how do I release without testing? It can be tested in the cloud, and we can actually release this particular software uh, I mean, whatever software we are trying to make in software-defined vehicles, this can be released over the air support. So this is the main concept of hardware coupling and hardware and software decoupling. So if you look into one of the definition from Sonatas, so Sonatas said that the fundamental functions. Why I'm taking Sonatas? Because Sonatas is a tier one. They were a GCC that was set up in India as well. So, for example, what is their perspective from the software-defined vehicle? They say that the fundamental function of software-defined vehicles, these are provided by software on top of advanced hardware resources and a modern operating system. So, if you look into the advanced hardware resources, what they were referring to is your SOCs, right? That is one of the very basic advanced hardware resources. We are looking at the implementation of your features on top of the system on chips SOCs provided by multiple vendors like NXP, Qualcomm, Renesas, etc. And that will be hosted on top of SOCs along with the modern operating system. So when we call about modern operating systems, we are talking about your OSs that are being made by Yocto, right? Like this is a Linux. We will be looking at the customized Linux versions, for example, Yocto or your automotive grade Linux, right? So based on these, this is kind of the hardware. This is kind of the software setup that I'm trying to talk, and this means that we can actually all the features can be improved over time because of this OTA support, and it is similar to what customers expect from other digital devices. So if you look into the Renault Group, right? So for example, Renault Group is an OEM, as you know. So for example, Renault Group, what they were looking into is the ability to upgrade a car throughout its lifetime, and they are concentrating more on on a concept called through a centralized architecture, right? So through a centralized architecture, that is like updating it and integrating new applications just to enhance its functionalities in its functions and functionalities. For example, when we call about centralized architecture, what does that mean? When we call about centralized architecture, we are talking about how the vehicles have transformed from distributed architecture to the domain centralized control architectures or the zonal control architectures. So if you look into the third party perspective of how they have defined a software defined vehicle, so this is one of the definition. What, for example, it comes from the Blackberry. So for example, Blackberry says that we are using centralized computing architectures over the air updates, advanced connectivity, sophisticated driver assistance, and then if they are also saying that these vehicles offer customizable user experiences that can actually integrate seamlessly with any kind of digital ecosystem. So why does BlackBerry is trying to define a software defined vehicle? Just because they are coming up with QNX or hypervisors. If you are there in if anybody is working in software defined vehicles, they might know why what I'm talking about. If they are saying that, okay, because of these tools they are trying to define about a software defined vehicle, it's not 100% true. The reason why BlackBerry wanted to understand about software defined vehicle is this one. they wanted to utilize the data that can be collected from the vehicles. So they wanted to utilize this complete data, and they wanted to use this data to improve safety, efficiency, and maintenance. So from the customer perspective, right, from the end user perspective, the software defined vehicle is actually is nothing but it is the majority of its features, right? Its features, performance, and user experience that needs to be delivered, enhanced, and updated through software rather than being fixed by the hardware at the time of purchase. So this is the exact definition of software defined vehicle from the customer perspective, from the end user perspective. So the end user always wanted hassle-free service, hassle-free updation of its features, of his car's features through software, and he wanted to look at how personalization and customization that can be applied across the vehicle lifetime. So if you look into the 8-layer SDV stack, right, a blueprint that can be used for the decoupled innovation, if you just look into it, so this is the complete 8-layer SDV stack that we would like to understand so for the next 10 minutes, I'll take you into these things. So basically, there is silicon that will be the foundational layer of your hardware component. So who are these silicon vendors? These silicon vendors are nothing but your NXPs, your Renesas, your Qualcomm, right? So these are the silicon vendors who are actually trying to come up with their advanced hardware resources. That's what one of the OEMs has have already defined a software-defined vehicle, right? So it is like we are coming with silicon where, for example, NXP, let us say NXP comes up with NXP S32K K144 and NXP S32K 344, right? And also if you look into the NVIDIA part, right, NVIDIA comes up with um Jetson NVIDIA Thor or Jetson NVIDIA Orin, right? So that they are being capable of running their AI models that can be run on top of your hardware resource. So for that, they are coming up with these kind of boards, etc. So this is like silicon vendors or the SoC side. That's the main fundamental basic building block of your software defined vehicles zonal controller, right? So based on this, we are also talking about, so the next thing, once we have a silicon, we are talking about the hardware abstraction. So the hardware abstraction, it actually provides a unified interface for all your hardware interactions. So basically, what do you mean by abstraction layer? So abstraction layer is something like it is the software equivalent of your hardware board, correct? That's exactly the name of it. I mean, the functions of it, like it provides a software equivalence for the hardware pins, whatever, or hardware pins or hardware memory or hardware uh, computing resources. It provides a software equivalent so that the upper layers can actually start using this particular hardware abstraction layer, right? So that's where this hardware abstraction layer comes in. The next one, and very important one and very new concept that is being driven in software defined vehicles, is your virtualization. So virtualization is nothing but it enables multiple operating systems just to run on a single hardware platform. So what does this mean? So whenever I say virtualization on a single, the goal of your software defined vehicle is to make sure on a single SoC, you wanted to run multiple functionalities. For example, there can be a QM component as well as an ASIL component that can run together. Right. So till now it is not been possible, but right now how we can make it is by we can use the concept of virtualization where your hypervisors will come in into place here, and they will try to run multiple applications on a single platform, right? So that's about your virtualization. And when you call about operating systems, I have already told you how operating system will work, like your Yocto or your AGL, automotive grade Linux, or a proprietary OS that is completely defined by an OEM. Those are the things that we are actually talking here, right? So operating system, the fundamental basic functionality of an operating system is to manage the system resources, and it can provide a platform for its applications, etc. So when I am talking about middleware actually facilitates your communication between software components. For example, what is middleware here? Adaptive AutoSAR, right? Classic AutoSAR is being one of the part of middleware, or a ROS middleware, robot operating systems, or a DDS, data distribution systems, right? So this is the middleware that can be facilitated to actually talk to it will be like a sandwich between your applications as well as your operating system or a hardware abstraction layer. So when we go a little bit top, we are talking about your vehicle services or applications, where these are the applications that we generally try to bring that customization that is being offered from the OEMs to the consumer. So these actually offer specific functionalities and the kind of services that the vehicle is looking for, right? I mean, vehicle is looking for in the sense the end user of the vehicle is looking for, right? So the other layer, we will talk about this in depth a little bit in the next slides. But the other layers are your DevOps, how you are going to integrate your development and operations for continuous improvement. Here, I would also tell you about how do you integrate the security as aspect as well. So that's the reason we can call it as DevSecOps. So how we are integrating all these things to continuously deliver your next available features. And on top of it, you're talking about the cloud, where the cloud actually provides your scalable and accessible computing resources. So we will also talk about it. So I'm in my previous seminars, right? I have already given most of the information about silicon hardware abstraction, virtualization, operating systems, and middleware. But I have not told you mostly on these other three things where I'll be covering it today. For example, let us directly jump into the sixth layer, your vehicle services or applications. So basically, how do you expect your vehicle services come in is like, we are trying to make sure we are writing our microservices. So these are your REST APIs or your gRPC APIs. So remote procedure calls, yeah. So these are the endpoints in which these endpoints will have all the information related to the sensors, to the functionality of the components, etc. So these are the APIs that will be exposed to the outside world and the other services, right? They whoever wanted to consume this particular REST endpoints or gRPC endpoints, they will consume it and they will take it into the system level integration. So I will also show you with an example in the next coming slides as well. So basically, there is an App Store SDK that actually lets your partners to publish their streaming as well as commerce applications. And there is a very famous acronym that is being coined right now around the concept of software-defined vehicles, which is nothing but FAS. FAS is nothing but your feature as a service model. So basically, what we are trying to do is we can actually use it as a subscription-based model where the users can pay it per month or per use or per mile. That is actually defined by the OEMs, right? So the other one is your UI, the user interface. It can be written in any language, even your Flutter, Qt. Your UI can be written in Rust as well. This can be used for your cross silicon portability. Not Rust, UI can be written using AAOS layers as well. So other things what we can talk is about your analytics, where your analytics loops actually decides which app tiles surface per profile. For example, uh, let us say there are 10 applications in your vehicle. So all 10 applications cannot be shown on the screen at once, correct? So what app requires the tile face is what is decided by the analytics loop, right? For example, contact information is being taken care by the user profile, etc. So this contacts folder or the contacts UI can be showcased on top of the screen as favorite section rather than putting the tile in the below layers, right? So that's one thing which I would like to talk about. And there is a safety wrapper that blocks distractions, that was already covered. And we are also talking about the how the Docker or OCA containers will have this particular 5-second restart. So what does this mean? So this means that let us say there are a bunch of microservices running together, and if there is any problem with any of the microservice and your microservice shuts down, right? So it is not going to have any impact on the rest of the microservices, because the other every microservice is independent and it can work. It will not collapse the complete functionality of your function what you have implemented. This particular function, this particular microservice where it has gone down or it has gone out of the sync, can have a 5-second restart according to the service legal agreement. So basically it will restart every 5 seconds, and it will try to restart every time. That continuous polling will be done until and unless it is completely restarted. If that is not the case, then there will be a report that will be generated and it can be sent to the service center, where the service center people or the service center people, they will understand what's wrong, and they can send the OTA update to actually run that. I mean, to actually replace that particular container altogether without disturbing the complete application functionality. So this is what I actually told you about, like data contracts, your safety wrapper, analytics loop, UI written in Flutter, feature as a service. This is a complete spectrum that actually shows the level of software control you are going to have in the service layer, in the vehicle services layer. So when we talk about DevOps, right? So even in DevOps, we have your CI/CD pipelines that can actually compile. So the basic functionality of DevOps is to make sure you compile the complete pipeline, and you scan it and you sign according to the cybersecurity rules, and then you version every build, correct? So that can be easily automated. So there's an end-to-end automation that turns this particular source commits into the signed release artifacts. So one more thing is your SBOM. SBOM is in the sense software bill of materials. So all the software bill of materials lists every library, so that the CVEs, what we call it, common vulnerabilities, that can be scanned through each gate before the merge. Right. So that is one more point I just wanted to highlight. And there is something called canary and AB flight plans stored as code. So what is this canary release and what is this AB flight, right? So this is basically when we are talking about your OTA updates. So canary is nothing but whenever there's an update that is being done by the software team, they wanted to test it on at least 5% of the fleet. That's exactly what we are calling it as a canary release. So any release that can be tested on this 5% fleet to actually go ahead and if that's a success, then what we are going to do is we are going to roll out to the complete vehicle fleet. So what is this AB flight plans mean? So AB flight is nothing but you have your RAM is divided into A and B. So where the present functionality will be present in B side, and whenever you try to implement or you try to run your new software OTA update, right? That can go to the A section of the thing. So where this, if there is a failure, it is not going to disturb the complete functionality of the software, and it can be easily rolled out, right? If A is a success, then it can go ahead and replace that B version. So this B version can be a new OTA update functionality that is being run. So in the same way, we have your rollback automation that can actually ensures a no break guarantee, and we have your test automation. So test automation is one of the feature that can be integrated into the DevOps pipeline, where your test automation triggers your hill and sill farms. So this actually this is also one of the thing that is being added together to make sure they have a complete hill and sill farms that can run in parallel. So yeah, Sorry. Okay. So there's one more thing which I wanted to tell here about the DevSecOps culture that is shifting, that are actually shifting your defects left into the code review. So what does that mean is we are trying to find out the defect as early as possible in the DevOps pipeline, and this particular thing can be like security and quality checks can run as pull request bots, and so issues whenever surface before merge can be easily fixed, and these fixes can be done in minutes rather than post integration firefights that will be occurring weeks later. So when we talk about the cloud, right now the layer 8 is cloud. So cloud is basically something what we are talking about the cloud services for automotive OEMs. So I'm not going to talk about AWS cloud or Azure cloud or Alibaba cloud, or I'm not going to go into that level. But what I am trying to talk to you is mostly on the superficial level and what kind of services are being used and what kind of metrics and what kind of features that we need to target. So basically, we are going to target about the hyperscale cloud, where you have your data lakes, digital twins, and AI that is being trained here. This is one thing which we can actually look into, and yeah, that's one thing which we can actually look into. And very important thing is your compliance, right? So your GDPR, General Data Protection Rule compliance, along with your ISO 27001, that is also regarding the data compliance, that is being baked into in from day one with encryption and audit trails. That is also very important, and we are also looking into the fleet orchestration. How does the fleet OTA works? How do we, what kind of rules and regulations that needs to be followed by the OTA updates in the fleet to push the binaries and pull the telemetry from millions of cars. And we are also looking at the elastic resources, because we have no infinite computation that is available. We need to make sure we have boundary rails and guardrails that we need to take care, we need to be taken care. And these elastic resources, right, they handle burst workloads such as your map updates and model retraining. So what elasticity doesn't mean that it is going only in the expanding direction. It can also mean that it can also look into the shrinking of your current resources when you don't require that much computation in the long run, right? So that kind of elasticity is very important to take it ahead. And there's something called API gateways. So basically we have multiple gateways. Your API gateways generally expose your vehicle data to the selected partners. So when we talk about API gateways, right, so API gateways, we in software defined vehicle, what I mean here is basically on your COVESA VSS specification, vehicle signal specifications. So these are the gateways that can be utilized by other OEMs also, and also it can be present in the cloud as well, right? So yeah, that's one thing I just wanted to talk about. And yeah, so there's one more thing one more thing that is very important, which you can look into is your digital twin. So a digital twin is nothing but your video game. It's like a video game copy of the real car. Okay, but it has some technical limitations. I will tell you in the next slide. But it's a video game copy of the real car that can never stop syncing with it. Right? This is a very easy idea of understanding what is digital twin. So it actually knows three things, right? Your shape and physics, your brain nerves and live signals, like from where your speed is coming, sensor is coming, speed data is coming, battery temperature data is coming, your map data is coming. So how it is going to sync in every second, and how because of it is always trying to fed by the car's own data. So then now the twin exactly behaves exactly like the car, even if the car is on the road. So basically, why do we require to build a digital twin? So these are the questions the owners ask. And this is how a twin will help us in the sense that the technical teams present in OEMs, it will help the technical teams in this way. Like for example, the questions owner asked was like, will this new software crash the car? So this is like a twin helps, right? Like first, we cannot give the OTA update then and there itself, right? So these OTA updates should be tested. So how do you test it? You test it in the twin first. In the same way, when will your parts wear out? So how do you understand when whether the parts wear out? We do the predictive analysis, predictive failures early in the twin itself and call the driver in before breakdown, right? And how can we ship features faster? This can be skipping some track days. The twin can help to skip some track days. It can actually run a million virtual kilometers overnight, right? In the digital twin. And the other question, the last question that they are looking into is how do we prove safety to the auditors? This can also be demonstrated using a digital twin by showing them a replaceable log of every corner the twin drove with every ECU response where they are able to document. So how do you build a digital twin here? So we can actually build a digital twin for vehicle monitoring where you can actually use it. First of all, these are the different steps. There are 7 steps in which you can actually start building your digital twin. Identify the problem, identify the niche problem, I would say. I just wanted to make that correction. Identify the niche problem because you cannot define everything and ask the digital twin to perform. You can, for example, you can actually define the specific issue to address, like, for example, your battery overheating, right? So how do you collect the data? The second step is how do you collect your data and how do you write your own model, right? It can be an MBD, it can be a model that is developed using machine learning, right? So you develop a basic model using physics or machine learning, then you start streaming your signals, like integrating this live data, whatever you are getting, right? So how do you integrate this live data into the model for real-time analytics? And then start comparing the results. Then you add alerts to implement by implementing them as a part of the dashboard for any kind of immediate feedback if you're looking to. Then you can expand your system, right? Gradually incorporating more vehicle components into the system. So these are the 7 steps that you need to follow to make sure you build a digital twin for your vehicle monitoring. So one of the case study I would like to bring in is basically on the Stellantis and AWS reference architecture and this key takeaways. So basically what happened here is the Stellantis SDV stack maps your cloud to silicon exactly on 8 layers. Whatever I gave, right, that 8 layers. So Stellantis SDV stacks also maps the same thing where your AWS IoT core, it actually handles your OTA and your digital twin as well, and even your edge devices in the car on the board, they were actually running by using this NXPS32G, right? So this is exactly what I have spoken to you till last from the last 20 minutes, how the 8 layer SDV stack is going to help you. So the basic takeaway here is by using the 8 layer model, you can actually decouple teams, suppliers, and release cycles as well. That's the basic takeaway which Stellantis and AWS reference architecture is following right now. And if you look into the selected building blocks, right? For example, this is one of the very famous building blocks of software-defined vehicles given by Augustin Friedel. So here also we are talking about your vehicle skateboards. See, for example, let us take one of the OEM. Let us take the same Stellantis, what we spoke about. So Stellantis is using the vehicle skateboard. So whenever, what is this skateboard? Skateboard is nothing but your EE architecture, your electronic architecture. So one of the skateboard it is going to take, and on top of it, it is using Qualcomm compute platform. This is the silicon vendor, and it is using Android, iOS, and also mobile drive. So probably Stellantis is working on the infotainment as well as your ADAS systems. And then this is an enabler for end user applications, your Amazon, and you have your user interface like Stellantis brand UI. And the complete cloud platform would be your AWS, Amazon Web Services, will be the cloud platform. So this is how your basic building blocks of software-defined vehicles work. But maybe this slides can be shared by Venkat as well after this particular session. So you can actually go ahead and read through it as well. So now I just wanted to take you guys into the demonstration. So you know what is a software-defined vehicle. You know what is the 8 layer SDV stack, which I just spoke about. So now you will be looking at how your demonstration of traditional workflow versus SDV. So what is generally I'm trying to do here is I want you to understand this driver portrait information system. So if you ask me like, hey, what are the components that are involved in this? It's a very general thing. I just wanted to show you. Like, for example, you have your camera module, you have your face recognition ECU, you have your HMI ECU, and you have a vehicle gateway ECU, right? So now what kind of communication protocols that we are trying to use? We can use a CAN, LIN, or FlexRay, right? You can use your RTOS or Linux as a OS, and you can use a AutoSAR or a non-AutoSAR based as a middleware. Correct? These are the total components that are required for your driver portrait information system. So let us try to connect all these things and see how things work. So, for example, so the driver portrait information system, there's a camera module which is actually capturing this driver information, and it is sending to the vehicle face recognition ECU, right? So this software of this face recognition ECU is made on RTOS or Linux. I mean, RTOS, real-time operating system for sure. That will be the OS. And on top of OS, you are trying to use your AutoSAR or non-AutoSAR based. Generally, right now, everyone is moving into AutoSAR. So autos are based middleware, and then you will write your software components, right? SWCs in AutoSAR to process images and match with the stored profiles. So once you have your information, it is going to send a CAN signal event to the vehicle gateway ECU, where this particular vehicle gateway ECU will be acting as a gateway between your face recognition ECU and your HMI ECU. And then this face vehicle gateway will be sending another CAN signal to the HMI ECU. Now this HMI ECU also will be written in your RTOS or Linux or AutoSAR or non-AutoSAR. And by the way, vehicle gateway ECU is the ECU that is also having it is also connected to the uh, s- uh, s- I mean, it also having the cellular connection to the cloud as well. So what is going to happen? What is the output of it? If the driver is detected, it says OK on the HMI. It's a hypothetical example. Okay. So if driver is detected, it says okay. If driver is at fault or it's not detected or is blinking his eyes, let us say it is an alert. So this is a traditional workflow. So how do you transform this complete traditional workflow into your software defined vehicle? I'll just show you before the limitations of this traditional approach. So basically, the limitations of traditional approach is like you are having multiple ECUs over there. You have a signal based communication delay that can happen. You can have a limited cloud connectivity that can happen, right? And you have a finally your difficult updates, your software upgrades require depot visits and everything, which is basically on the software upgrade side as well, right? So now looking into the next one. So now how this SOA based workflow, the service oriented architecture is going to help you here. Now the same thing is there, but there are some different ECUs come in place, right? For example, a zonal controller, which you didn't see it before. And there is again a vehicle gateway HPC. I'm talking about a high performance computer here, right? So what is happening over here is, let us say the way the driver's information is being captured and pre-processed by an edge AI camera. So the camera before and now is completely different. And this information is shared to your zonal controller, where the zonal controller is made by using this RTOS or GPOS, and on top of it a SOA based middleware. SOA based middleware in the sense, let us say it is done, I mean, it is the software of it is made by adaptive AutoSAR, where all the information will be your microservices. I mean, not microservices. Your all your applications will be your REST APIs or a gRPC APIs that will be published over Ethernet or IP to the vehicle gateway HPC, right? So what is happening here is the HMI, right? I don't see any HMI connected in this one, but there's a HMI that can subscribe. This is the most important information. This digital cluster can subscribe to the zonal controller hosted services. So whoever subscribes to this one, they'll get the information, and it then gives the same information like if the driver is detected, okay, if the driver is not detected, it's a fault, right? And your vehicle gateway HPC will receive all the updates from the OTA over there using the cloud services, right? So this is how the difference between the traditional workflow and a SOA based workflow in a software defined vehicle. So if you wanted to know the more understanding of it, so where exactly this data is being published from and who consumes it, so this is how the source works. Like for example, the source, like the zonal controller, what you just see here, it has different sources. Like for example, it has driver authentication service, it has fatigue detection alerts, and a driver behavior data. So these can be published using these protocols. Some IP DDS or MQTT, or a DDS or MQTT, or some IP MQTT. And who subscribes to this is your infotainment services, your digital clusters, your clouds, etc. Right? So basically, where we will be using your some IP. Some IP is used for your AUTOSAR based SDVs, adaptive AUTOSAR based SDVs. That's the publishing mechanism in which how you will publish your data through. And you have, for example, if you have a real time data exchange or real time data streaming that needs to happen, we will be using DDS. And if there are any kind of cloud and IoT integrations, we are going to use your MQTT as well. And a little bit more, because there I have seen multiple people asking me what is the difference between a HPC and a zonal controller. This is exactly how HPC and zonal controller can be differentiated in this particular example. Like it actually, I mean, zonal controller and vehicle gateway HPC both sends authentication statuses. They process authentication. I mean, zonal controller process authentication, but vehicle gateway will not. And all your cyber security, data aggregation, and direct cloud connectivity will be done by using your HPC, not by the zonal controller. So what are the key benefits of this for HMI? So by using this Ethernet IP subscription, there are no hardwired signals. You don't have a CAN message signal that is connecting between all these things. It can be a less hardware or no hardwired signals, like dynamic communication can happen, unlike the scan based signal mapping. And this is there is a real time updates that can happen, instant authentication status without polling. And your scalability, of course, it's on the move. And you can also have your cloud connectivity as well. So in the same way, let us see, there is one more example, one more small example I would like to show you. So what's happening here is that 12 cell temperature sensors just like this, and this information, the sensor information is being captured by the battery ECU. And now the battery ECU with a software stack implemented in classic AUTOSAR. So the basic software reads these values, aggregate the values, and convert the aggregated value to degree centigrade and sends to the application layer. So this is how the it actually works. So you have a range ECU which actually calculate the value from the battery ECU, and based on the range ECU, right? Now this range ECU algorithm will calculate based on the all the temperature sensors that are coming in, and it finally sends a message saying that, hey, you have only 212 kilometers left. So something like this. So how do we make it in how do you make it in your SDV workflow is mainly on this one. For example, this can be used. This can be done by using ARM SOC. For example, your zonal controller will be having an ARM SOC. On top of it, you have your safety certified Linux kernel, right? This will be a completely safety certified Linux kernel. Um, that will be on top of it. You will be having your system services, right? Your Dapper sidecar injector, or your Mosquito broker, or your adaptive AutoSAR, etc. And you have a container runtime, and on top of it you have two containers. One is your battery safety container and one is your range advisory container. Okay, so battery safety container, which is an SLC container, and range advisory container will be a QM container. Now understand it very clearly. What this battery safety will do, it will try to publish the information of all the sensors, etc., onto this topic, battery slash alert slash over temperature. If this over temperature is, let us say, 1, okay, here I have given here, if temperature is greater than 70 degrees, then over temperature warning is 1. So what will happen? If over temperature sensor is 1, then every 5 seconds, a scheduled task in the range ECU kicks in, waking up the ECU, digs through the latent temperature, battery logs, etc., and it will try to come up with a new range estimate to the instrument cluster. Right, so that algorithm kicks in every 5 seconds. So that's exactly what will happen. So if so someone has to poll this information, and who is going to poll this information? The other container, the range advisory container, will try to poll this information via what? Via a REST API, because it wanted to consume a REST API coming from this topic. So range advisor will try to pull that information, and if it finds that okay, hey, this is the information you are having one here, so immediately what is going to happen is you can actually take that information and you will start recalculating that algorithm, and it is going to send it to the instrument cluster like this over the CAN payload. Okay, so this is how things work in software defined vehicle. So yeah, so I think that's all from my side. I have made this session very intuitive, like what is exactly required from software defined vehicle to understand on based on what are the use cases that we will be taking into. So yeah, and remaining things, the question, this PPT will be shared by Venkat to probably the video will be shared in YouTube if I'm not wrong. So yeah, so I'll be handing it over to Venkat. So Venkat, any questions?
Yes, Mr. Pratap. There are a couple of questions on the chat window. Do you want me to read
Okay.
them?
Yeah, let me take it. Yes. Sure. So yeah, Sivabalan. So whether zonal control is same as DCU, domain control unit, if I'm not wrong, Sivabalan. I'm thinking it is as a domain control unit. So, see, I'll tell you, zonal controller, the name, yes, thank you, Sivabalan. So the name of zonal controller is a concept, okay? That is a standardized concept across industries, I mean, across OEMs. So this zonal controller, nobody says it as a zonal controller, right? They'll say it as a domain control unit or see, there's again a lot of difference. I really don't know whether in the particular OEM where you are working or a tier one where you are working, are they referring domain controller and zonal controller to the same? That I'm also not aware, because there are multiple things here. Zonal controller controls the complete zone. Domain controller controls only the respected domain. Like for example, it can actually contain. I mean, it will actually try to take only the domain related information. For example, your let us say infotainment or your powertrain, chassis and safety, right? But a zonal controller will control your powertrain. It can control your infotainment. It could also control your telematics as well. That all defined by the EE architecture team in the zone. That they will define what is zone, what is not a zone, etc. Hope I have answered your question. So the next question from Mohammed Kaif is: does having a digital twin completely eliminate use of actual? No, no, no. Digital twin doesn't eliminate the use of actual car prototype. Actual car prototype, I mean, digital twin is a how do I say it? It is a copy of your uh, exact car in the cloud. So why are we using digital twin? Because every time we don't wanted to test the functionalities in the actual car prototypes, right? It is not possible. So in order to reduce the cost of testing your applications on the actual car prototype, we are trying to use your digital twin. Okay. Yes, from Venkat, ASIL and QM systems can coexist with memory partitioning. Yes. What's the needs of hypervisor? Great. The reason why we are using hypervisor is to orchestrate the virtual machines. Okay, there, because now memory partitioning, that is also right, but how we will make it as we will have virtual machines that will be orchestrated together using this hypervisor. So all these virtual machines will be sitting on top of your SOCs. So inside virtual machines, you have your containers. Okay. So in the containers, I mean, I'm talking only on the application side of the complete stack. Okay. So on the application side of the complete stack, on in the virtual machines, you have your containers. So these containers can coexist with your ASIL and QM systems. Right. So, and how is software universally decoupled from hardware as claimed in SDV? Testing on target hardware is always yes. You are right. Testing on target hardware is absolutely necessary because we need to have a hardware prototype at the end of the day. That is true. Nobody is going to take it out, right? There is a concept called GTM, right? If you understand, go to market. So your SDV concept is where you will try to bring up your functionalities and then try to run these functionalities quickly and try to send it to your customers, right? So, and also you can easily prototype most of the features than waiting for months together or years together to arrive at a complete car prototype. So this is actually enhancing the date of your go to market. But the actual testing on the target hardware is absolutely necessary, and there's no negation for that. Okay. If new microservice software is having some failure, then will that microservice switch to older software without you? No, no. The microservice is a packaged module. It's a packaged module altogether. So if there is a failure in the microservice, right? As I said, it will try to restart. It will do multiple restarts by its own. But if that is also failing, then it is going to send a report to your uh, to the, let us say, the end of the, at the end you have you're a service center, so you are getting a report for it. Then using OTA update, you are trying to replace that particular microservice. So user intervention is necessary for replacing the microservices. Sure. Any other questions?
Folks, we have the mic access available now. If you have any questions you would like to ask Mr. Gupta, you can go ahead. We'll keep the session on for another 5 minutes. I'm also posting the feedback form on chat. Kindly take a couple of minutes to fill it up.
Hello, Pratap. I have a question. So, is it possible for you to draw a simple visual diagram of how this hypervisor works?
Mhm. Um, just give me a second. How a hypervisor works, right?
Yeah, just like so you say like there is this it's like kind of like a virtual machine, right? So it's like some kind of VMware or something
Mhm.
similar to that, and how like different is it like based on like multiple systems are in a hypervisor or something like that? I can't really visualize it, so that's why I'm
Yeah,
asking.
sure. So basically, okay, let me take you like this. There are containers, there are virtual machines. Okay, hypervisor actually orchestrate virtual machines. This is my statement previously, correct? So containers will look like this. For example, let us say this is a complete software stack. You have your hardware SoC. On top of it, you have OS. On top of it, you have middleware that is, yeah, that is there. Okay, but I'm trying to represent, due to representational purposes, I have just put Docker runtime here. So on top of the Docker runtime, we have multiple containers. So what is meant by container? Container will have application libraries and dependencies that are packed together to form a container, correct? So that there are two containers which are running on the Docker runtime. This is what your containerization concept is. And what is this? This is something like your hardware is there, and on top of it, you have your hypervisor. So hypervisor orchestrates virtual machine 1, virtual machine 2, and both of the virtual machines have their OS and applications and libraries, correct? So this is how two different concepts are. Now we will go to the next slide to see both of the concepts merged together. This is exactly how your hardware, on top of your hardware, you have your hypervisor. So even hypervisor, they are calling it as, there are two types of hypervisors, type 1, type 2. One is bare metal hypervisor and another is non-bare metal hypervisor. So bare metal hypervisor, let us say if there is a bare metal hypervisor, you don't require a OS. You don't require a OS. And hypervisor is also called as the logical extension of your operating system. This is a very important definition that most of the people don't take it into consideration. Hypervisor is not different. It is an OS, but it's a logical extension of your existing operating system, so that that particular hypervisor will have a super functionality, which is nothing but it can try to orchestrate VM1 and VM2. Okay, what do you mean by orchestration? Like the hypervisor will try to allocate the resources for whatever virtual machine is running. Hypervisor will try to make sure it will support the functional safety. Okay, like for example, VMware is down, VM1 is down, virtual machine 1 is down, right? So it should not affect virtual machine 2 because these two are very different virtual machines. And also once it is down, then it has to try to restart by its own. So who is going to do all these activities? The hypervisor will try to do all these activities. Managing the resources. See, whatever OS operating system is doing, hypervisor will do. The only thing is it will try to do on your virtual machines.
Okay.
Right. Okay, great.
Thank you, Pratap.
Thank you. Any other?
There are a couple of questions in the chat.
Okay, yeah. If a new function in an SDV is based on a subscription, then will the vehicle always come with the hardware for it? It's a very good question, Mohammed Kaif. So OEMs will decide how much computation should be available. Okay, I'm talking about computation. I'm not saying hardware, etc., etc. Okay, because as both of us know, whenever we are talking about hardware means memory, computations, etc., etc. Okay, but for any feature, in order to run that particular feature, you need to have computation. Okay, so we'll stick to that. So OEMs will decide how much computation should be available in the car. Okay, so based on that, the game will start. The game is how do you create your applications such that those applications, any new applications, okay, how do you create this new application such that these applications will try to use the existing computation that is given by the OEM. Okay, so if a new function in an ASDV is actually based on a subscription, then there is a huge chance that there will be a swap of the functionalities. For example, what is existing in the car might not be available at that time. That particular computational memory, that particular computational characteristics would be associated with the new function probably, right? So that's how the OEM is going to decide on. Okay, so I think I see these are the questions.
There is one other question before that about digital.
Okay. Do we have any specific standards for these 8 layers? This one? Sriram Rajya Raman.
This has been just added. There is one other question before the question.
Considering a digital twin is created for a Model G car, does a digital twin replicate the exact condition of the car? That's the duty of the engineers from the cloud services who should feed in this particular data so that it will actually replicate the exact condition of the car with the wear and tear of the vehicle is used. If yes, how it's possible? Okay, how it's possible? If I tell you how this is going to be possible, it is going to take another 1 to 2 hours of session. Okay, but how it is possible, I have already shared it here. For example, just give me a second. I'll share this one. Okay, let me share my screen once more. Okay. I have already given here what kind of, how to build a digital twin. Probably this can help you again. So we need to identify the problem. For in your case, how do you mimic that exact functionality, that niche functionality? Then you collect your data, then you create your model, then you stream your signals, then compare results, add alerts, and expand your system. This is how the flow is. But if you want me to explain everything in it, how the things work, it will go out of the session as well. So that's why. But you can actually stick with this particular flow and try to mimic your understanding with whatever available in the outstanding resources, whatever available, you can actually mimic to that. Okay, so any other questions? I think that's it.
The last question around Vashira. Do we have any specific standards for these 8 layers?
Specific standards. Okay, I'll type in chat itself because everyone is trying to put it in chat. So these are the specific standards that needs to be fulfilled for all the 8 layers. Okay, to get the permission to sell the vehicle in EU region. Okay, so what are these? R155, R156. Just Google it. You will understand what is R155 and R156. One is for cyber security, one is for OTA. Yes, some send CS, yes. For any application that is deployed in SDV architecture, which standard to be followed to check the latency and performance? Latency and performance, it is see, basically there is no standard as such which I am aware of to actually go and check the latency and performance. It's the general standard whatever we are using. But these applications should be complied with ISO 26262, right? And R155 and R156. Okay. So anything else, Venkat?
I think that's it, Mr. Pratap.
Thank you. Thank you. Thank you, team. Thank you very much. Yeah. Bye-bye.
Thanks everyone for joining in. I've shared the feedback form on the chat window. Kindly take a couple of minutes to fill it up. Any other queries, any other feedback you would like to share, you can do it in the feedback form.